Hey, let's talk about solving complex centroids. So before we can solve complex centroids, we do have to know kind of what a centroid is. A centroid is your center of mass or center of gravity. So let's talk about a couple simple centroids before we get started with the more complex ones. So if we're looking at something like a square, square looks kind of like this, right? So squares have two measurements that, or squares or rectangles have two measurements that kind of make them what they are. They have a base and a height. So first of all, a square has square or rectangle has an area of equal to base times height. Okay. So you've got that, and then when you're looking at your centroid is going to be located here in the middle for a square or rectangle, and that centroid has a certain location in space based on our height and our base. So if we're considering this point 0 on a graph here, your centroid is going to be located x bar away from this point in the x direction and y bar away from that point in the y direction. For a square or rectangle, your x bar is going to be equal to your base divided by 2. Okay? And similarly, your y bar is going to be equal to your height divided by 2. And that puts you right smack dab in the middle. Okay? Another simple shape that we use often when we're calculating complex centroids that we need to know about is a right triangle. Okay? So right triangle looks sort of like that. Put the right triangle symbol in there. And then just like the square or rectangle, a right triangle also has a base and a height. Okay? Its centroid is located somewhere about there. And just like the square or rectangle, that centroid is going to be located in space x bar away from the origin and y bar away from the origin. Okay? The area of a triangle is equal to 1/2 base times height. So there's multiplication there too. Your x bar for a right triangle is going to be equal to your base divided by 3. And your y bar is going to be your height divided by 3. Okay, so a couple simple shapes, a couple more to go here, and we should have everything we need to calculate a complex centroid. So the next one that we're looking at here is going to be a circle. Circles are pretty easy. Your circle's centroid is going to be the center of your circle. So right there. That center is always located r away from the edge of the circle, or radius. Okay? So that's not too bad. But what is a little bit more complicated is when we have what we call a semicircle. Okay? So semicircle or a half circle still has a radius, so it still has this radius here. So that's your x bar, right? So if we have this point, your x bar is just going to be equal to the radius. Your y bar gets a little bit more complicated. So your centroid is located in this area here. Your y bar is going to be equal to 4r, so your radius, divided by 3 times pi. Okay, so this one is a bit more complicated. So this is here, is your y bar. So that one's a little bit harder. Okay. If you watched the other video, you would know that you've got some scary looking equations that give you your complex centroids x bar and y bar, and then if you're doing a 3D shape, the equation looks very similar for your z-bar also. So x bar for a complex centroid is equal to the sum, that's the sum symbol, of the individual shapes. So in a complex shape, we're going to break them down into smaller, easier to manage shapes. So it's going to be equal to the x bars of the individual shapes times their area. We're going to sum all those shapes up, and then we're going to divide it by the sum of all the areas, so the total area. Okay? So that's your x bar, and then y bar is going to be equal to the sum of the individual y bars times their area multiplied by the sum of the areas. Okay, so let's look at an example now. So I'm going to draw a shape that's going to look as close as I can to my least favorite superhero. So we get this shape going here, just like that. Looks sort of like this, right? Kind of like a Superman symbol, just like a 45-degree angle. So that's the shape that we're going to talk about solving today. Solving complex centroids is a 9-step process, but the steps are broken up into little tiny bite-sized pieces that are pretty easy to manage. So the first step is to divide our complex shape into simple shapes. So what I'm going to do is I'm going to divide this guy down like this. That's one shape. And then we get a triangle, and I didn't do a very good job drawing this, so this is going to be a rectangle, this is a right triangle, and this guy's actually going to be a square. Step number 2 is to determine our reference axis. Okay, so we need an axis to reference later to make sure that we got everything right. So we're going to use this as our y-axis. We're going to draw this guy, make it our x-axis, like that. And then obviously those lines are supposed to be touching the axis, but I'm bad at drawing sometimes, so it makes it a little hard. Step number 3, we need to know a few things about our shape before we can get started with step number 3. We're going to call this point 3 inches, call this point 6 inches, and then right across from that dotted line is also going to be 3 inches, and that guy up here is going to be 6 inches. Okay, so now we need to calculate the area, which is step number 3, of each individual shape. So we're going to call this shape 1, call this shape 2, and this shape 3. So the area of shape 1 is equal to base times height, which is equal to 3 times 6, which is equal to 18 inches squared. Okay, that's area of 1. Area of shape 2 is equal to 1/2 base times height, which is equal to 1/2 3 times 3, which is equal to 4.5 inches squared. Area of shape 3 is equal to base times height, which is equal to 3 times 3, which is equal to 9 inches squared. Okay, so that's step 3. Step 4, we need to determine the location of the centroid of each shape. Okay, so for shape 1 is a rectangle, so its centroid is going to be here, which in this case is going to be, in the middle, so you have to divide those in half just like the rectangles. So its height is 6, so divide that in half, you get 3, so it's going to be up 3 and over divided 3 in half, 1.5 from this point. Okay, shape number 2 is a right triangle. It looks like this. Make sure you can see that. And its centroid is here. It has a 3 side and a 3 side, so if we divide both of those by 3, you get 1. So it's going to be up 1 and over 1 from this point. Okay. And then shape number 3, it's a nice square, like that. At this point, its centroid is going to be here. That's 3 this way, 3 that way. So it's going to be up 1.5 and over 1.5 from this point. So that's step 4. Now we know where the centroid of each shape is. Step 5, I'm going to redraw my Superman shape so I've got a little bit of room, because step 5, we're going to determine the distance from each shape's centroid to the reference axis. So we're going to draw the shape again, maybe more to scale this time. Maybe not, who knows. We're going to divide that guy back up into our simple shapes. We're going to put a point for their centroids, just like that. Alright, so I should probably draw the reference axis too. That guy going, put back in like that. Alright, so we need to determine their distance from the reference axis, and that's what we call X bar and Y bar respectively. Alright, so this first one was easy. Remember shape 1, we measured 3 up and 1.5 over from this point. This point happens to be here, so that makes it really easy. This guy is going to be 3, and then this guy is going to be 1.5. For shape number 2, it's 1 up and 1 over. 1 up starts here, so it's 1 up from this point, but this point is 3 up. So this is actually 4 from the reference axis. Okay? And then if we go this way, we knew that it was 1 over, but this guy starts out 3 over, so it's actually 4 over from the reference axis. And then this guy starts at the reference axis here, so that stays 1.5. But for this one, it starts 3 over this guy. So over is actually going to be 4.5. Okay? So that's step 5. We determine the distance from each simple shape's reference axis. The next step I like to create a chart to do the next one. Just helps me out keeping everything straight. So in this chart, we're going to need shape, we need area of the individual shapes, we need the X bars of the individual shapes, and then we're going to need the area times X bar of the individual shapes. Okay, and we have 1, 2, 3 shapes. So then I'm going to make this nice table, just so I can keep everything nice and organized. Just like that. Alright, so area of shape 1, if you remember, was 18. I'm going to write that in a different color so we can see it. Area of shape 1 is 18. Area of shape 2 was 4.5. Area of shape 3 was 9. Our X bar of shape 1 was 1.5, right here. 1.5. Our X bar of shape 2 here is 4. And our X bar of shape 3 was 4.5. 18 multiplied by 1.5 is 27. 4.5 times 4 is 18. And 9 times 4.5 is 40.5. Okay, so we've completed that table. Now we need to make a similar table for our y values. So we have shape, we have our area, we have our y bar values, and then we have our multiplied area and y bar values. We have 1, 2, 3 shapes, and we can create a nice table. Like that. Columns going, get our rows going, just like that. Luckily, we already recorded some information in our top table, so we know that this is 18, 4.5, and 9. Okay? Our y bar for shape 1 was 3. Our y bar for shape 2 is 4. And our y bar for shape 3 is 1.5. So when you multiply 18 by 3, you get 54. When you multiply 4.5 times 4, we already know that one, it's 18. And when you multiply 9 by 1.5, you get 13.5. So those tables are going to help us out a lot when we get to step number 7. Alright, step number 7 here, we're going to use our tables here. We're going to use them to kind of get the top of our equation. So what we're looking to do here is get the sum of the areas times our x bars, which in this case is going to be equal to 27 plus 18 plus 40.5. So if we add that guy up, we get 85.5. And then we also want to sum up our areas multiplied by our y bars, which in this case is going to be equal to 54 plus 18 plus 13.5. Add those guys up, and then it's also equal to 85.5. Okay, so that was step 7. Step 8 is a pretty easy one. Step 8, we're just going to sum up the bottom of our equations that we need. So the sum of the areas, and in this case it's going to be equal to 18 plus 4.5 plus 9, which is equal to 31.5. Okay. And then all that's left to do for step 9 is to solve our equations. Right? So our x bar for our centroid is equal to the sum of the areas multiplied by x bar over the sum of the areas. So it's going to be equal to 85.5 divided by 31.5. It's going to be equal to 2.71. Okay, not too bad. Our y bar is going to be equal to the sum of the areas multiplied by the y bars divided by sum of the areas. Okay, that is also going to be equal to 85.5 over 31.5, which is also equal to 2.71. Okay. So if we're looking at that guy, we're going to draw our complex shape here one last time. It's going to look like this. Just go kind of like that. Boom, boom. Alright, so we know that this point in space here is 3. We know this guy 3. So we know that just off of that a little bit would be our 2.71. We know this is 2.71. If we connect the dots here for 2.71, our centroid is going to be right there. Okay. Coincidentally, you'll notice that if I put a mark here in the middle and I draw a line just like that, that is our axis of symmetry. Okay, So anytime that you have a symmetrical object in any direction, the centroid is going to be located on that axis of symmetry. Okay? So that is how you solve a complex centroid using the additive method. There is another method where we would take our complex shape here, right? And instead of dividing it up into 3 shapes, we would have, we would do this to complete the square, okay? So we would have a really big square, and then we would have a triangle that looked like this. And then when you're adding things up, you would subtract instead. So you would subtract the centroids from the sum equations, and you would subtract the area from the summing equations, okay? So that would end up being a negative number here because you're missing this portion of your shape. So if you still got questions, feel free to let me know. I hope this helps you out.